follow along, try everything that we're doing. And I'll go ahead and get it turned over to Jeff.
Hello, everybody. I'm excited to give you this presentation on volatility. I worked pretty hard on it, and we're basically going to be going over, how to acquire an image. Once you do have that image acquired, how do you find the pertinent IOCs for whichever, whatever you're investigating, or just how do you find information that you want to find based on your own criteria? How do I skip this? Right there? All right, sweet. Give me a second, guys. Sorry, guys, some Zoom technical difficulties here. Okay, so what is volatility? Volatility is a framework of open source tools for analyzing digital artifacts or pieces of evidence from RAM samples or volatile memory. So volatility is cross-platform, and modular and extensible. So what that means is you can run volatility analysis on any number of operating systems. Most major operating systems have some way to create a memory dump, so create a dump of all the RAM and data contained within for analysis. So down at the bottom, hopefully most of you guys have already downloaded Volatility, which has been kind of part of our syllabus, as well as the memory sample. But if you haven't already, you can go to volatilityfoundation.org/releases, and you can find for your operating system of choice or distribution of choice a copy of Volatility. So Volatility is for analyzing memory images, but how does one acquire a forensically sound or just a memory dump from RAM? So you see over here, I've got a listing of tools for major operating systems and how to acquire that memory dump. We'll go through SDK Imager here in a little bit. Dump it I've used, but they won't be a sign up for registration, so I don't really like them. I want to have a direct link. Access Data does as well, but I already have an account. So it's pretty much a matter of just whatever's most convenient at the time between those two tools for me. For Mac OS, we have Recall, which is open source. You can clone that repo from GitHub. And with Linux, everybody loves Linux. You can just disk destroyer or DB your memory. There is a special descriptor for memory that you can dump it. And as always, define the block size as 1 megabyte, so you're not writing tiny little writes each time, especially with the amount of data that RAM can encompass, such as 4 to even 64 gigabytes, maybe 128, who knows what the future holds. Okay, so if we have a computer that we want to create a memory dump from, and I heard an example earlier where we had a scenario where an individual did something on a computer, did some type of behavior or activity on a computer, and it wasn't shut down. So how can we acquire, evidence or artifacts from RAM that would be indicative of an infection or, say, malicious or activity that we don't want or desire? So in order to acquire this image, we would download SDK Imager, which is free software. All you have to do is register. You could use a throwaway email account, 10-minute mail, mailinator.com. Those are a few of the ones that we use when we don't want to register or throw away our PII for just a software download. So I would definitely download a copy of SDK Imager. Hopefully you guys already have it so that you've been able to play around with it and kind of form any questions for us. But we'll assume that you've already done that. So in order to acquire a RAM image for the purpose of memory forensics, in Access Data, you will click on File, then Capture Memory. You'll be provided with a place to select your destination path and then a file name. So where am I going to put this dump and what am I going to name it? You can also include the page file, which pagefile.sys, hybridfile.sys, like Lynn was touching on earlier, they do contain a lot of pertinent and very interesting pieces of evidence and artifacts from memory. Some of those, I don't know if anybody's used the tool bulk extractor. You can actually run bulk extractor, which is open source as well, on pagefile or hybridfile.sys, and actually dump a lot of those artifacts really quick. I believe it's using a function of grep. But anyways, this is how you do a memory dump with FTK Imager. Do we have any questions up to this point on creating an image or a memory dump, or what a memory dump means, or what that is, what that entails? All right. So for the purpose of memory forensics, we'll be analyzing a sample of malware. It's from a little while ago, but it's still applicable for our analysis purpose. That will be a variant of Cridex malware called Cridex. So if you look, I've got a GitHub URL where if you go to the access that URL, you'll be able to download a copy of the Cridex malware for analysis with volatility. So at this point, I'd like for in the chat. Yes, I'll go send that link over in the chat as well. Let's see here. You can send it on my that user. So let me just send over. We kind of swapped computers here for the presentation, but he's going to send over a link through chat that will contain the Cridex sample for our analysis. So could I have everybody, or at least if anybody's not able to acquire volatility or this sample, could you please let us know? Otherwise, we'll go ahead and move forward with the analysis and assume that everybody else has got a copy. Or if there's any other questions, now's the time. Otherwise, we'll move into the kind of commands that we have for volatility. Okay, so we're going to go ahead and go into the commands that we have for volatility. Give me just a second here to make sure my presentation is running right. Can everybody see that? Can you see that? Yes. Okay. So if you will load, or I guess open a command prompt or command window, a terminal, and basically we're going to be running some commands for volatility to start processing or at least analyzing this forensic memory dump. So we see a list of commands. These are some common commands that you can find. PS scan, find exited or deleted processes, but really it's any kind of process scan that you're doing, and it will basically locate, kind of like Task Manager does, a list of processes. DLL dump, I've not personally used that, but it is allows you to export basically dynamically linked libraries that were loaded into memory at the time that the snapshot was taken. Command scan, we have a list of what I'm imagining the command line history would be. So much like Linux has the history command and your bash history, I'm sure that Windows has command history that command scan will find. File scan, we'll look for open file descriptors. So if a rootkit is hiding a file descriptor from your Explorer process or from Explorer's visibility, you should be able to find if a file is open. So a good example of that would be processes that hide. So a process that hides from a process list in PS scan or Task Manager file scan has been touted to find those hidden processes. And we'll kind of delve more into that as we go into screenshots and kind of working with the Cridex malware sample. So IE history is a command that can find some malware in an Explorer or iExplorer. And there's numerous different commands, but this is kind of a top level generic. If you want to have a kind of shortcut or a Cliff Notes version of how do I run volatility, this is going to be the command set that you're going to want to utilize. So let's go ahead now and move into volatility, analyzing the Cridex malware memory image that we have acquired through GitHub. And using the information that we've acquired to determine IOCs, indicators of compromise, and kind of identify the attack. So the first thing that we're going to start with is running this image info command. The -F means specify a file, and the vmem is going to be a virtual machine export of a memory snapshot. So when we run image info on the cridex.vmem file, what we see is suggested profiles. So this is basically telling you, hey, I recognize from the memory activity on this dump that it matches the operating systems. We see address space layers, PAE, I forget what the acronym stands for, but we basically see if we see the configuration of the machine that we created the dump from. And what that allows us to do is then specify a profile. So this is, the suggested profiles right here, XP Service Pack 2, XP Service Pack 3, x86 architecture. That's probably what we're going to want to try to define as the memory source or the source of the dump. So we'll take volatility, we'll take its recommendations and apply the profile. So we've said volatility, run with this file, that's Cridex malware from a virtual memory dump. It looks like from your reporting, it's a Windows XP Service Pack 2 machine with 32-bit architecture. And what I would like you to do is print the key of software Microsoft Windows current version run. So I've, in another life, I have developed malware, and one of the big processes of malware is persistence. And what persistence involves is writing to your registry to have a local file run every time you log in or every time the Windows process is instantiated. So what you see is a lot of times malware authors will they'll write a key, and so it makes sense for me as a malware investigator to say, okay, I know what malware I'm investigating, I know what computer I'm investigating it on. Now, what keys from the registry do I want to dump, knowing all those previous factors? So you see, we have this KB file. So I've gone ahead, since I've known that it's been Cridex malware, right? I've gone ahead and looked up the list of IOCs. I found Sophos, they did a great job of threat analysis on Cridex. And so what I'd like to bring attention to is that this, while this isn't the exact file name, the behavior is starting to line up. So if I look, okay, this key was created, and they're using, looks like KB, and if I were to regex that out, I would say it's KB with 8 digits, randomize it. Maybe start with 00. But still, they're generating a in an area of a user profile, so the application data. There's a file that's supposed to run with a very nondescript file name that happens to match some of the behavior of Cridex malware. So from just dumping registry keys of run and basically knowing behaviors from malware that we investigate and malware that you guys investigate, we can kind of start to pull a list of IOCs together and say, hey, this is starting to line up with Cridex. Do we have any questions up to this point? Okay, so let's look at active connections. So with volatility, as you'll see as a theme, we have to specify the profile. That's a standard CLI switch that we say. So you're going to see that in every command that we're running. But once you figure out the profile, it's a one-off determination, and then once you've established that, you can then just run that command. So what we're wanting to do is dump a list of connections. So if you think about a malware evidence perspective, if you're local and somebody says their computer had evidence of a virus, most likely, in my opinion, and that's how we've kind of run this training, is I would do what I go through as an IT engineer with physical access to the computer is what I need to run through a volatility. So I'm checking the startup file, run files. I'm checking TCP connections with netstat, but I can't do netstat, so I have to use volatility connections. I'm checking for malware being resident in memory and RAM. So all those things that I'd be doing if I had access to a physical machine, volatility allows me to do. So basically, if I search for connections associated with the memory dump of Cridex, I get a list of a local or a source IP and a destination or a remote address with a process ID. So if I were to reverse look this up or compare or correlate this data, right, with a Sophos listing of IOCs for Cridex, then we'll see that we found this match. So we found that 41.168.5.140 on port 8080 with process ID of 1484, that's being accessed. And we know that access of that specific address and port appears to be an indicator of compromise for Cridex malware. So already at this point, from just kind of utilizing, from my experience, IT behavior and IT processes for investigating malware on this exact computer, from just the running a run keys from the current Windows current version run subkey, and then looking at TCP connections, so the equivalent of a NetStat, is almost enough to give me IOCs for Cridex. So here's, we were talking about the PS scan. Here's another alternative or similar command called PS list. So going back in here, if you recognize the PID for this process. So I'd be very interested in whatever process is trying to access a URI or a URL that has been associated with Cridex malware deserves investigation. So knowing that process ID, let me look at what other processes are running and let me see what it's tied to. So I'm running Volatility. Like always, I pass my profile that I'm running and the file that I'm analyzing, but also following up by the command that I want to run on those, but on the file with the profile selected. So here you see a list of processes. Now, all these on the PS list side, you see are true, and PS scan is true. So PS list, PS scan is a command for Volatility. PS list, I believe, as well. But basically, if you see a malware process that is hidden from Task Manager, you should see false in one of these columns. So if we see a process, and I would just say randomized letters. So say we saw that KB process, right, from, go back here. So say we saw this KB process from this test user's account or Robert's account. We saw a KB 00207877, but we saw, when we looked at this PS list or PS scan, we saw it was false. What that indicated that process was hidden from a task manager or process scanning function, and that we should probably investigate. At least I would want to investigate something that was hidden, because if you have to hide, what do you hide, in my opinion? So we basically get a list of all the running processes from here, and we're looking for hidden processes, but we're not finding anything for this particular scenario. So if we look, the reader SL is the process, let me see here, actually. So 1484 goes on Explorer. Sorry, man, getting ahead of this. 1484 is on Explorer, and what we'll commonly see is malware utilizing a technique called process hollowing. And so what process hollowing does is it takes an application that's already allowed to run on the system, and it carves out a section of that approved memory, and it writes its own code. So it's injecting code into a known process. So a lot of malware does that to avoid or evade detection. So what we'll see on this finding malware slide is we see Explorer.exe, the process ID. And sorry, I'm skipping ahead. What we need to do is, we know that there's some activity from a TCP connection right here going on at port 8080. We have a process ID assigned to it. So what I'd like to do is I'd like to dump that process executable and the memory layout that it had at the present time of the image for further analysis. So if you see here in this slide, we've been able to identify that reader SL. So PID is your process ID. PPID is your parent process ID. So what we see is this reader SL application, and then we see it belongs to Explorer. So that could easily be a process hollowing of reader SL into Explorer.exe. So because we have these two PIDs or process IDs, why don't we dump the memory storage as well as the executable? But there's also a built-in command with Volatility called malfind. And so that's what we're going over right here. So our precursory analysis of looking for connections or looking for user or run keys for Windows shows us a few IOCs that pan out. But this is kind of like a technical or an analytical way to say, okay, I know that my human analysis shows that it's probably malware, but is there a computerized or systemic way to validate malware? So this malfind command in Volatility will run again against your memory dump with the profile you've selected, which is also indicated in image info command. And so malfind is indicating that it identified some weird malware or malware-related activity or activity that appears. It doesn't have to be guaranteed, but it appears to be malware. So what we see here is we see reader SL and we see explorer.exe. And one thing I'd like to bring to light is there's a something called magic bytes in forensics. So a magic byte is, I think, the first 4 to 6 bytes. I could be off the exact quantity, but it's bytes, the very first of a file that is an indicator or a descriptor of what the file's content after the magic bytes should contain. So what we see is MZ over here are the first 2 bytes. So MZ is indicative of a executable. So what we're basically saying is search this memory dump with this operating system, most likely, and find us malware inside of memory. And so Volatility is coming back and saying, hey, because I know the executables start with the MZ header, here's all of the portions of memory that contain the MZ header. So at this point, there are multiple things in our analysis that came back for Cridex malware. But these were the 2 process IDs or processes that caused the most attention, because you think, why does Adobe's reader have a malware activity here? So it makes sense. So what we want to do is, not all of us can be malware experts. I can't be a malware expert. I just know the behavior. I know some of the indicators, but I can't be up to date on malware. We've got penetration tests, forensics works. So we have to have some type of automated system to be able to scan for malware so that we can save the work of manual analysis. Of course, we always do follow up with manual analysis, but we like to get all the grunt work or all the busy work essentially done by a computer. And that's what malfind does. So now that we've identified process IDs that are associated with malware on the image dump, or on the memory dump, excuse me, that we've created on a system that we believe was infected with malware, Cridex malware, we're going to actually put these to files. So you'll see the commands I've run on Volatility, proc dump and mem dump. So proc dumps is going to dump the process with the process ID. You see the -P, that's the process ID we're dumping. And we define a dump directory. Of course, the dot means current directory. But this whole command will basically take a PID that we have identified as potentially malicious with malfind, and it will place it under our file system for further analysis. So what you see here in our dumping process is the memory. We have dumped from the Cridex snapshot 2 process IDs. Out of those 2 process IDs, we've dumped both their executable and memory space that they were taking up. So you see over here on the side process, this is, it looks like to be a pointer, image-based pointer as well, but we have the name of the executable and then the output labeling of the executable from Volatility. So what we would like to do is examine executable.1640.exe as well as the dump from memory for 1640. And we want to examine the executable.1484 as well as the dump from process ID 1484. Do we have any questions or any feedback up to this point? All right. So now that we have all of those IOs, now that we've located a process in memory that has suspicious activity, that is correlated with IOCs for no malware, now it's almost like we have this golden ticket. Now how do we look at it and see what's inside of it? So as a web developer, I like to not like to, but I picked up a few tricks and a few pieces of knowledge along the way, as well as writing my own malware simulators. I have picked up a few pieces of knowledge and kind of methodology for determining what an application is trying to access. So if you see here, I'm going to use the strings command. So I don't know how many people are familiar with Linux, but strings is an excellent command that will basically pull out ASCII strings from any binary or any file. And we can always pipe. So piping is it's part of the pen testers and Linux users arsenal. If you don't know about piping, that'd be something to definitely look into. It's very effective and highly dynamic for searching for data. So what we're going to do is dump out a list of strings from 1640, which is our process ID for the suspected malware. So in the strings, I then want to filter that through a filter for HTTP, because keep in mind, most of this malware is going to be communicating over HTTP or SSL connections, which is going to be HTTP or HTTPS. So there are ways to hide which protocol you're accessing for a HTML request or HTTP request. But malware authors in general are lazy, and so are most software developers, speaking from software development myself. So we don't do that much obfuscation, potentially, or especially people that write malware, because no one really reverses your malware, except for people like us. So we take the strings from the memory suspected malware, we pass it through a filter for the word HTTP, then I just want the top 5 results from all of that. And what you'll see is we have this HTTP 188.40. I don't know if everybody can see that top line where the mouse is, but you see the cp.php. That's usually indicative of a control panel PHP shell. But I don't know everything, so we can't assume. What we can see here further is we've got this account.authorize.net. So I'm going to wonder already, if we look back here, 1640, why does Adobe Reader trying to access authorize.net? That right there would be a, that's kind of strange. That this Adobe Reader process that Volatility identifies as malware is trying to provide HTML for authorize.net, a payment authorizer. That's really strange. So then you could think, okay, what do I need to look for? Now, granted, we have cheated essentially, as in we know it's Cridex malware. So we kind of know as educators or trainers what to look for. So we kind of took some shortcuts. But if you didn't know it was Cridex malware, just grepping out the strings or looking for, essentially searching for strings within those dumps can provide you a very good indicator of what you may be looking for. You'll see here I utilize the same strings command on the same dump from reader.sl.exe installed in C program files Adobe Reader. It's starting to look weird. So then I grep out the word bank. So here's where it gets a little bit more interesting. We not only have Adobe Reader accessing what looks like a PHP control panel from some IP that I'm sure we could geolocate to some foreign country or outer space. Then we have also the same reader SL process is, these look like wildcard DNS entries, right? So you'd be wondering, why does Reader SL or why does Adobe Reader need access to these wildcard Bank of America, TD Bank? Something's looking weird. Something's off. So 1484 is what we're going to look at next. So we've got explorer.exe. So when I dump strings for 1484, now I know that they're probably trying to send stuff over HTML or HTML post request. So I want to tell me what strings are associated with my Windows Explorer.exe process. Now look for the word method equals post. So then I start to see words like inject form for chase.com from Explorer.exe, which Reader SL is utilizing. So it starts to become strange. All of these, what looks like Reader SL, Adobe Reader, Windows Explorer now has all these pieces of artifacts or evidence now that match IOCs are indicative of infection with Cridex. So taking all that knowledge, typing strings or using strings. So I'm using an asterisk and an asterisk. So it basically means anything that has the word 1484 in the file. I don't care what the extension is. I don't care what it starts with. I just need all my dumps from this particular process ID. And so, building on what I learned before, I went to grep for port 8080 and an HTTP request. And then you see here in explore.exe, we have lots of URLs or URIs that match IOCs for Cridex malware. So I have these files and I have these URL strings, but if I'm going to give a presentation or if I'm going to report this to a higher up, I need something that's solid or tangible proof that this is truly a IOC, not just I think it is, but everybody in my industry believes that this is an IOC. So everybody's familiar with VirusTotal. If you're not, you should be. VirusTotal will allow you to search by URL, file upload. I believe there's other search mechanisms, but essentially, if we take the IOC or not IOCs, but even some of these strings, so this 188.40, if we take that string and we paste it in, or 41, whatever, into VirusTotal, it can detect that that URL has 5 virus engines or signatures associated with it. So then I start thinking, okay, that looks, okay, maybe this is Cridex malware. Everything adds up. So let me dump in another URL. Okay, 3 engines. So I'm starting to look indicative that I think this has Cridex. So we've been able to export, right, the executable for reader sl.exe and explore.exe at the exact snapshot of time that the memory dump was taken. So a simple drag and drop to VirusTotal shows us that yes, 32 engines detected in executable 1640, which I believe is reader SL. And then what we have is 26 engines detected in explore.exe, which again, if you're process following and reader SL is opening up memory space in Explorer and then injecting malware, Explorer will also register malware. So I think that's a good, any other questions? Any other feedback? We'd love to answer some questions, man. We nerd out about this stuff all day. And so if you have anything about looking for malware in resident memory or RAM or creating memory dumps or searching for IOCs, we'd love to answer those questions. Otherwise, we'll go ahead and move forward to network forensics. All right, guys. I'm going to go ahead and turn it over to Lemon, and he'll give you that presentation on network forensics here.